Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we look at exponential models. We're going to use exponential models to solve real-world problems. So one obvious application is through compound interest. So let's say I invest $6,000 at 4% per annum interest compounded annually. How much money would I have after 8 years, and how many years would it take my investment to triple? So before we look at these questions, let's look at why this would be an exponential model. So what's happening is you're investing some money. So you start with year 0, you start at 6,000. So after year 1, this will increase by 4%. So to increase something by 4%, you times it by 1.04. So at the end of year 1, you'd have $6,240. At the end of year 2, you'd take your $6,240 and increase it by 4%. And similarly, at the end of year 3, you'd take the amount you had at the end of year 2 and you'd increase it by 4%. So now you'd have $6,749 and about 18 cents. So let's look at the increases. So from year 0 to year 1, we went up by $240. The next year, we went up by $249.60. And then the next year, we went up by $259.58. What is happening here is the amount you have is increasing at an increasing rate. Went up by 240, then by 249, then by 259. So the next year might go up by around 270, and then the year after that might go up by 285. This is increasing at an increasing rate. So this is a model of exponential growth. It's going to get big really quickly. So the equation, if I let y be the amount of money I have and x be the number of years, the equation linking x and y is an exponential equation. What I would have is the amount is what I started with times 1.04, because that's what I times by to increase by 4%, and that would be to the number of years. So after 1 year, it was 6,000 times 1.04. After 2 years, it's 6,000 times 1.04 times 1.04 again. So the quick way to get this number is 6,000 times 1.04 squared. And this is 6,000 times 1.04 cubed. So you can see this fits our definition of an exponential model, y equals a times b to the power of x. So 6,000 is our initial value, and 1.04 is the growth factor. It's growing because this number is more than 1, and we could see that it was growing in our example over here. So after 8 years, the amount I would have would be y equals 6,000 times 1.04 to the power of 8. And that gives me approximately $8,211. Much easier just to use this equation than to go year 4, year 5, year 6, and so on. So how long would it take my investment to triple? So what I'm going to do is I'm going to use this equation again. So if I want my investment to triple, I want to have $18,000. So I want y to be 18,000. So I just substitute y equals 18,000 into that equation. 6,000 times 1.04 to the power of x. So dividing each side by 6,000, I get 3 is 1.04 to the power of x. Now this is not easy at all to solve. It is not at all obvious to what power I raise 1.04 to get 3. But remember, we looked at equations like this in previous lessons. So what we could do is use a graphical method or logs. So if you know logs, this is really simple. You would just go log of 3 divided by log of 1.04. Put that in your calculator and you get about 28 equals x. So that means it would triple after about 28 years. So if you wanted to use the graphical method, you would graph y equals 3, y equals 1.04 to the power of x, and you would do that on your graphics calculator and get your graphics calculator to calculate the point of intersection. So the answer you get is about the same value for x. The intersection is about the point 28.3. It's not exactly 28, but it's very close. So same answer, it will take about 28 years to triple. All right, let's now look at a harder question where it's going to be a bit more difficult to come up with the equation. So let's try this question. I invest some money that's compounded annually, have 14,178 after 4 years, 16,596 after 9 years. What's the initial amount and growth factor? So we know that compound interest is an example of exponential growth. We saw that on the previous slide. So we know our equation is going to be of the form y equals a times b to the power of x. So here y being the amount I have and x being the number of years, just like on the previous slide. So we know that a is the initial amount and b is the growth factor. What makes this question harder than the one on the previous slide? On the previous slide, you were told the initial amount was 6,000 and the growth factor was 1.04 because that's what you times by to increase by 4%. So here I don't know either of them. What I'm going to need to do is substitute in these points. They're points because we have an x value, number of years, and a corresponding y value. We have an x value and a corresponding y value. So let's start by inserting this point into this equation. So I get y is equal to a times b to the power of x. Doing the same for the other one equals a times b to the power of x. So now I want to find what a and b are. So this is kind of like a simultaneous equation. What I want to do is get rid of the a's. I can actually get rid of the a's by dividing one equation by the other. Now, it doesn't matter which equation you divide by which. It's probably easier to divide the larger number by the smaller number. So if I go 16,596.91 divided by this number, I get 1.1705987. I just did heaps of decimal points to be accurate. So if I go a divided by a, they cancel out. That's why I did this. And then b to the power of 9 divided by b to the power of 4 just gives me b to the power of 5. So if I want to find what b is, I'm going to take the fifth root of each of these. In your calculator, you just put this number to the power of 1/5. And the answer you get when you put that in your calculator is very close to 1.032. So remember, b is the growth factor. So when you times something by 1.032, that's an increase of 3.2%. So that's the growth factor. The investment is going up by 3.2% each year. So we're not done. We need to find what a is, but that's really easy. We can just take our answer here and substitute here. We can substitute b for 1.032. So then, of course, a will just be 14,178.14 divided by b to the power of 4. And the answer we get here is very close to 12,500. So I started with 12,500 and it's increasing by 3.2% each year. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.